Alright, this is chapter 9.6, problem solving, and our job is to find a rule. And that's what we've been doing lately in math. Let's read through the problem. On an archaeological dig, Gabriel separates his dig site into sections with areas of 15 square feet. So there's kind of a little picture there. There's a couple of sections, and each section is 15 square feet. 15 square feet inside each of the little squares. Oh, inside each section of the square. So I see that they've kind of drawn a line down the middle. Let's read that again. On an archaeological dig, Gabriel separates his dig site into sections with areas of 15 square feet. There are 3 archaeological members digging in every section. Okay, so if we were to say there's 3 people in each section digging, there we go. What is the area of the dig site if 21 members are digging at one time? So we have to make a chart, and we've been practicing making these. The question is what you need to find. What do I need to find out? And it really says, what is the area of the dig? Oh, getting a little ahead of myself there. If 21 members are digging. Members are the people digging. At one time. But we can just say digging. Okay, so this is the question you're trying to answer. What is the area if 21 members are digging? So first of all, we know that each block is 15 square feet, and that inside there are 3 people, 3 members digging in each block. So there would be 3 in this one, and if we would keep going, there'd be 3 in this one. And we're going to make a chart like we worked on yesterday. So we've got our sections, and we have numbers of members. So there's 3 in the first section plus 3 more. So number of diggers, or members. It's hard to write that small. Hopefully you can read it. And then the final one is the area in square feet. All right, so we can start working this out now. Now, in the first area, this is area number 1, we see there are 3 members, and the area, every square is 15 feet. So you need to get out, you need to keep filling this in, just like it shows you in the problem, and then we have to work out what it will be when there are 21. So if we go 1, 2, 3, 4, 5, 6, 7, and we count by 3s. 3 times 7 is 21. But if we count by 3s, 3, 6, 9, 12, 15, 18, 21. Okay, we can see that the rule is that we're adding 3. And down here, we can count by 15s. Well, 30. So there's 15 in this one, and plus 15 is 30. 45. You might have to use your calculator for that, but it's in the book, so you'll probably be okay. 75, 90, and then what comes next? It would be 105 if you're just counting by 5, by 15. We're adding add 15. Okay. So, but the question is what are we multiplying by? When we go this direction, we're multiplying, and this is the important thing. This is something you really need to be paying attention to. How do I get from 7 to 21? Yes, and multiply by 3. And how do I get from 21 to 105? Well, that's a little harder. But let's check to see if the pattern holds consistent. Is 1 times 3 3? Yes. Is 2 times 3 6? 3 times 3 is 9, so the multiplying by 3 works. What about from 3 up to 15? 3 times 5 is 15. So that's kind of what we're working with. 3 times 5 is 15. 6 times 5 is 30. What's 21 times 5? It's kind of a calculator problem. We go up here and we go 21. Oh, that says 22. Here we go, 21 times 5. And it should be 105 if we've done everything right. It looks like it is. 105. So that's a good deal. And you should be able to fill in everything else on the page now. This is basically how you're going to do everything. You're going to have to make charts and figure out what the pattern is and figure out what the multiplication rule is. Let's look at one more and then I'll kind of leave you on your own. Casey is making a design with triangles and beads for a costume. In his design, each pattern unit adds 3 triangles and 8 beads. $18 beads. There we go. That makes a little more sense. All right, so there's a picture of his triangle, and then he has another one, and his triangles are equilateral and mine are not perfect, but that's okay. You'll forgive me. Inside each triangle, he puts 6 beads. There's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You can see that there are 6 beads in each of 3 triangles. And we could start building our chart right now without even reading the problem. But we shouldn't do that. If Casey uses 72 triangles in his design, how many times does he repeat the pattern unit? How many beads does Casey use? So if he uses 72 triangles is what we're looking for. And if we go ahead and build our chart, we're going to just remember that on our last chart we called it sections. Well, these aren't sections, these are pattern units. So we'll just call them units. And then we're just going to have to make, I should use the straight line tool. We're going to just have to make some. I don't know how many we need. And I'm probably not going to help you finish this problem. I'm just going to get you started. So use the paper to solve the problem. Draw this out and we'll kind of see where we get. We've got 3 things again. We've got our units, which are just going to be like 1, 2, 3, 4, 5, etc. I don't know how far we have to go. And then the first thing is 3 triangles. So he has triangles, and there are 3 of them, and inside each set of triangle are beads. And there are 18. So in the first one, this is the first one, there's one set, and it has 3 triangles, and it has a total of 18 beads. So if we added another set, we'd be counting by, we're going to add 3, just like we've done before. And down here we're going to add, I keep forgetting to write that A, because it's a lot like the D's. We're going to add 18, and that might be calculator use again, because 18 plus 18 is 36, and some of you know that, but not everybody does. Up here it's easy, 3, 6, 9, 12, 15, etc. But our next question is, how do we get from here to here? And then how do we get from here to here? And when I work on this, 1 times 3 is 3. So I'm multiplying by 3 again. And let's see if that works. Is 2 times 3 6? Is 3 times 3 9? Sure enough. And how do I get from 3 to 18? I multiply by 6. So whatever this, 6 times 6 is 36. 9 times 6 is 54. 12 times 6, do you know it? 72. And it might be time to get out your calculator, and you can fill this in. What's the number we're looking for? Oh, I might have given away the answer. We're looking for 72 triangles. Oh, this is 72 beads. we're going to have to go a ways to get to 72. We're going to have to go a long ways. So let's see. 72 triangles is a ways out there. So how do I get to 72 using 3? Well, 3 goes into 72, not 77. You can write this down on your paper. I need to see your work. 3 times 2 is 6, and 3 times 4 is 12. So 3 times 24. So 3 times 24 is equal to 72. So I would have to go all the way out. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, up to 24. Instead, we can just put 24 over here. We're going to skip a few. And once we do that, once we know that it's 24, it's the 24th pattern that he uses that he gets up to 72 triangles. Because 24 times 3, there's 3 triangles in each unit, is 72. So that's really complicated. But now that you know it's 24, you can multiply by 3 to get the number of triangles. We already know that that's 72. And then you can multiply 72 times 6 to get the number of beads that he's going to have to use. And that's a lot of beads. I'm going to let you do that all on your own and have a good time with this assignment.